Okay, welcome back. This is ELM Prep, Part 6. Shapes, a little more shapes, but we're talking about triangle this time, triangles. So, the triangle is quite often problematic to a lot of students because the concepts become a little hazy in terms of perimeter and area. Perimeter isn't too bad, but area becomes tricky. So let's start with the basic idea of a square, where all the sides are in fact equal. So the area of this is side times side. So area equals S squared. Well, if we have a triangle, we could create a triangle here simply by chopping this square in half and taking half the area for the triangle. Well, it looks like we cut it in half. We could have cut it this way, but that wouldn't have formed a triangle. So we cut it diagonal and we formed a triangle. Well, we can see intuitively that the area of the triangle is half. The area of the triangle is really half the area of the square, or side squared. Well, one of the things we notice, and by definition this is a right angle as all the other corners are, so this would be a right triangle. The right triangle has the unique quality that these two sides are perpendicular, and if it were a isosceles right triangle, these two sides would be equal to each other. And then that would make these opposite angles equal to each other, but we'll talk about angles later. So, the basic idea of the area of a triangle is 1/2 the area of the square. Well, that's okay, but what if I don't have a square? What if I have a rectangle? The question is, does that idea still hold true? Well, let's divide our rectangle in half. So sure enough, my triangle looks to be half of the rectangle, and it is. Well, sometimes in triangles, we call this the base, and we call this the height. It's nothing more than a fancy way of saying length and width. Well, we know the area of a rectangle is length times width. So the area of the rectangle would be length times width. Well, half of that would be the area of a triangle. So the area of this triangle would be 1/2 the length times the width, or in this case we call the length is equal to the base and the width is equal to the height. So we'll substitute for length and width. We'll call this base times height. Don't let the fact that we call this a base and a height confuse you. It's just one side and the other side. Length and width, base and height. And the triangle is half of that area of the rectangle. So that's where this half comes from. Okay. So if I want you to know the area of a triangle, I have to tell you something about the triangle. In some manner, I have to tell you the height, and I have to tell you the base of the triangle. Now this is obviously not a right triangle, or may not be, and it certainly doesn't look to be half of a rectangle. But if I were to just draw a rectangle around this, you can possibly see that this area is half of the rectangle. This area out here is the additional part. Well, it still holds true that my area of the triangle is 1/2 the base times the height. Well, if I told you the height and the base, and I set this up and I said, okay, what's the area of the triangle? Well, you know the base and you know the height. The height is the same as the width here. So the rectangle would be base times the height. I would just take away the 1/2 to get the rectangle. But we want the area of the triangle, so we're talking about 1/2 the base times the height. So regardless of the shape of the triangle, they're going to have to give us base and height, or some way to think about that. Well, they might have told us this. They might have drawn that triangle inside a rectangle, and they told you length and width of the rectangle, and we'll say it's a 7 by 4 rectangle. Well, we have to do some interpretation here to get the triangle portion. Let's shade our triangle in here. Well, we know it's 1/2 the base times the height. So where's my base? Oh, my base is the length. So they told me that in sort of a roundabout way. They said it was 7, and they told me the width of the rectangle was equal to 4. So there's my height equals 4. So this distance, this vertical distance, would be my height. And so I can figure out what the area of the triangle portion is. So don't let this confuse you and go, oh my God, what do I do now? Just look at it, try and figure out what they're asking you. Are they asking you the triangle portion? If they are, they're going to have to somehow give you the base and the height. Now, they may not give it to you directly, but in some way they have to give you enough information so you can figure that out. Otherwise, you're just left with the general base times the height, 1/2 the base times the height. So what if I have a triangle that looks sort of like this? And they draw a line out here. And they tell me that's my H. And they say, well, that's 5. And they tell me my base is 3. Well, my height isn't inside my triangle, but I know that the area of a triangle is 1/2 the base times the height. Well, they told me the height. Even though the height is perpendicular out here, it's outside the triangle, we're still going to go by the base times the height and take 1/2 of that. So don't worry about the fact that your height may be outside of your triangle in terms of their drawing. So a triangle is just 1/2 the base times the height. Okay. Well, in terms of perimeter, perimeter is the 3 sides. And if they're asking for perimeter, they're going to have to give you A, B, and C in some way so that you can add A plus B plus C to get the perimeter. Now, they may be a little tricky about how they do that, but somehow they're going to have to give you that information so you can get the perimeter of the triangle. It's not as easy to find as if they gave you the height and the base in terms of area. They're actually going to have to give you all 3 values to find the perimeter. All right, so triangles, we're either going to have all sides to find the perimeter. If we're looking for area, we're going to have the base and the height. And then we're going to take 1/2 of that amount. Okay. Triangles. They can be kind of tricky, and they may even do, I'm trying to think if there's something they might do with a triangle that's kind of strange. They might do something like this. And they might tell you that the radius of the circle is 5. Well, they didn't tell us the height here. We could assume that this down here is the base, but the question is, what's the height? They didn't tell us. Well, they did in terms of the drawing. This went up here, so this distance is the radius. So the radius out this way is the same radius up there. So I know my height is equal to the radius, which is equal to 5. And I know the base is actually 2 radiuses, or a diameter. The base is equal to 2 times the r, or the diameter. So then I have 5 times 2 is 10 times this, and then I'm going to take 1/2 the base, which is 5, or sorry about that, 1/2 the base is 10, or 2r, times the height, which is 5. So 1/2 of 50 would be 25. So that's a tricky one that they could give you. They'll just give you a circle and a triangle inside, and they'll tell you the radius, and then they'll let you interpret the information. That's probably the trickiest one to interpret, and you just have to realize that the distance from the center to the top of the triangle is in fact the radius. So let me see if I can do this a little differently. Let's say it's over here. And of course the one up here would have had to been perpendicular. They would have had to tell me that these were in fact equal. So let me go backtrack a little bit on this circle idea. Let's say my triangle was over here. Well, now, even though this is a radius out here, it's not the height, because the height is a perpendicular value. So the radius is not going to do me any good in this case. They will have to give me information that will let me interpret that. They might tell me, they probably either have to give me the height directly or some information which I can interpret and use Pythagorean on. But we'll talk about Pythagorean later. All right, so let's call this a day. Ooh, ran a little bit over on that. I apologize. That was about triangles, and hope that was helpful. Have a good day.